So we're going to focus in on this problem from the homework. Graph all asymptotes of the rational function. We've already kind of worked with some of these, but we're going to start with our vertical asymptote that's made by our denominator of a rational function. So in our case, it's made by this. And it's really whenever that denominator would equal 0, we can't exist. So that one's fairly straightforward. We're just going to say x plus 1 cannot equal 0. So where does that happen? Well, minus 1, x cannot equal negative 1. So that's where our asymptote goes. So in our case, we would go to negative 1. We would actually click this button and would drag it over to here, and we would have a dashed line here. So that part's fairly straightforward. Now, remember on the horizontal asymptote, if the degree of your numerator, so if the degree of the denominator, let's do that, denominator is greater than the degree of your numerator, then your horizontal asymptote, your h of a, is y equals 0. If your degree of your denominator is equal to the degree of your numerator, oops, this would happen when your hand rests on the screen, then your horizontal asymptote is equal to the leading coefficients. So this would be a over b, right? So it would be that leading coefficient. In this case, it would be negative 1 over 1. Because there's a negative 1 in front of the x squared and a 1 in front of the x. If the degree of the denominator is less than the degree of the numerator, you either have your horizontal asymptote is equal to a slant asymptote, or is a slant asymptote, is a slant asymptote, or your h of a is none. Those are the two options if the degree of the denominator is less. In this case, the degree of the denominator is 1. The degree of the numerator is 2. And we've talked about degrees of denominators already. Or degrees of polynomial functions. So in this case, let's see if I can get that to pop back up so I can erase that or undo it. Maybe I can just do that. I don't need that. There we go. Alright. Sorry about that. Alright, so we either have none or we have a slant asymptote. The way to determine that is to do this long division. So this says negative, dang it, it's still in erase. Go back to ink, change the color. Let's do that color for this one. Ink. So, negative x squared minus 3x plus 3 is going to be divided by x plus 1. The only way to get negative x squared is to multiply x by negative x. And that's going to, negative x times x is going to be negative x squared. Negative x times Positive 1 is going to be negative x. We're subtracting, so that changes this sign to a plus and changes this sign to a plus. Negative x squared plus x squared goes away. Negative 3x plus x is negative 2x plus 3. This is like saying I'm in the hole $3 and I get $1, so I'm still in the hole $2. Now, the only way to get x, this x, to equal this is to multiply by negative 2. Negative 2 times x is negative 2x. Negative 2 times positive 1 is negative 2. Same situation. We're subtracting it. So that becomes a positive. Put that in a circle. This becomes a positive. There we go. Negative 2x plus 2x goes away. 3 plus 2 is 5. So I have a slant asymptote, and it is right here. So this is my slant asymptote will equal this. Formally, I might write this as SA is equal to the line y equals negative x minus 2. And remember from way back in the first topic, we are graphing this. So we start at the point negative 2. This is our b, or our y-intercept. So that's this point, negative 2. And then because we have a negative x, that is negative 1 over 1. So I go down 1 and over 1. And I have another point, down 1 over 1. And from that I can draw the dashed line, but we would be using this, and we would place it, we would put 1 point here, 1 point there, and it would automatically graph, but I'm doing it by hand. So we're just going to try to be careful. And it would go this way, right? So it would go. I'm off. There we go. Right. Pretend that was a nice straight line. And now we would have graphed all the asymptotes of this function. I hope this is helpful.